For millennia, we've looked up to the stars and wondered about the nature of the universe and our place in it. How big is the universe? How old is it? What makes the stars shine? By performing fundamental research to answer these questions, scientists have helped advance our collective knowledge, bringing benefits to all of humanity. But far from extinguishing our curiosity, the answers we find lead to new questions. What is the nature of gravity? Does the universe only have 3 dimensions of space, or are there more to find? Why did all the antimatter produced in the Big Bang disappear, leaving a universe made of matter? What is the origin of mass? Here at CERN, physicists from all over the world have come together to answer some of these challenging questions. To further our understanding of the laws that govern the universe, we smash together particles at high energies and record what happens when giant particle detectors, such as the Compact Muon Solenoid or CMS experiment. The Large Hadron Collider accelerates protons to nearly the velocity of light before colliding them inside the very heart of the CMS. The energy of the colliding protons transforms into matter, spraying particles in every direction. The CMS detector acts as a high-speed camera, recording collisions 40 million times a second for further analysis. The LHC is helping us explore uncharted territory. The Large Hadron Collider occupies a 27-kilometre underground ring located 100 metres below the Swiss-French border near Geneva. It is the most powerful particle accelerator ever built, and it's designed to collide protons together up to 40 million times each second. These collisions take place at 4 points around the ring. At each collision point sits a large particle detector. Each detector is built and operated by different international collaborations. CMS and ATLAS are the 2 general-purpose detectors, designed to observe any signs of new physics that nature might manifest. CMS stands for Compact Muon Solenoid. It gets its name from the fact that at 15 metres high and 21 metres long, it really is quite compact for all the detector material it contains, and it's designed to detect particles known as muons very accurately. And it has the most powerful solenoid magnet ever made. The detector weighs 14,000 tonnes and has around 75 million individual channels for detecting and identifying assorted particles. CMS is made of several layers, like a cylindrical onion. The innermost subdetector is the silicon tracker, which registers the trajectories of charged particles. The next layers are the electromagnetic calorimeter and the hadron calorimeter, which collectively measure the energies of electrons, photons, and composite particles called hadrons. Then comes the solenoid magnet itself, and finally the muon detectors that make up the outer layers. Data from collision events that are potentially interesting are stored for further analysis, and the uninteresting ones are discarded. Analysis itself is performed around the globe, using the worldwide LHC computing grid that connects thousands of computers in many countries into a single framework. CMS has published over 300 scientific papers so far, with 64 petabytes of data collected and analysed until the beginning of 2013. The CMS experimental site is located in the French commune of Cessy, about 10 kilometres away from CERN's main campus. Excavation of the large underground cavern that houses the CMS detector began in 1999. During early digging on site, the engineers came across something unexpected: the ruins of a Roman villa dating back to 309 and 315 AD, with broken coins and pottery. The second challenge was expected. The diggers would have to get past an underground flow of water. CERN engineers dealt with this by freezing the water, digging through it, and applying concrete as they prepared the 100-metre deep shaft. Meanwhile, the CMS detector itself was being constructed on the surface, with parts sent to Cessy from all over the world. CMS is designed in slices. After construction, each slice was lowered through the shaft into the experimental cavern, and then assembled on the floor. The heaviest slice, weighing 2,000 tonnes, took around 10 hours to be lowered into a very delicate operation. In 2009, CMS recorded its first collisions between protons, and there were celebrations across the globe. On the 4th of July 2012, CMS announced the discovery of a new particle to the world, now confirmed to be Higgs boson. Physicists continue to search for many new particles and phenomena to resolve the many remaining unanswered questions. Discovering the Higgs boson in 2012 has helped cement our knowledge of how fundamental particles in the entire universe gain mass. This was just the first step of the LHC, and it'll take years to study the properties of the newly discovered particle. The accelerator has been built with a long-term exploration in mind. Our best understanding of all the particles in the universe and 3 of the 4 known forces that govern them is encoded in what is known as the Standard Model of particle physics. However, despite decades of correct prediction after correct prediction, physicists know that the Standard Model does not show us the whole picture. Theorists have proposed several extensions to the Standard Model, many which include predictions that can be tested at the LHC and CMS. These include searches for dark matter and extra dimensions, as well as explanations of the matter-antimatter asymmetry of our universe.
The LHC accelerator started a new run in 2015 at the highest energy ever achieved by a particle accelerator.
This new realm is expected to provide a wealth of new data, which CMS scientists will eagerly analyse for years to come in the hopes of unlocking more of nature's most closely guarded secrets. The compact muon solenoid will operate for at least another 2 decades, undergoing a steady evolution over time. New subdetectors are being manufactured, existing ones are being upgraded.
A new scientific journey has just begun, and we are really looking forward to this continued adventure into looking at the deepest secrets of nature.